What causes pressure of a gas? We know that by definition, pressure is equal to thrust per unit area. Thrust means perpendicular force divided by unit area. So let's look at an example of gas that is contained in a vessel. And for convenience, let us say that it is a cubical vessel. So we know the molecules inside are all moving in random directions, and as they move, they constantly collide with the walls of the container. When they collide, they exert a force on the wall of the container. This force that is collectively exerted by the colliding molecules on any wall of the container divided by the area itself gives us the gas pressure. So let's calculate what is the pressure exerted by these gas molecules as they move. So let's consider a molecule of mass m that is moving to the left, and then it's impinging or colliding on this wall. So let's say the velocity of the molecule is negative v as it is moving to the left. Then it goes and hits on the wall of the container, and it rebounds with the same speed v. We know that because we understand that the collisions of the molecules are perfectly elastic, so therefore it rebounds with the same speed without any loss in kinetic energy. From Newton's second law, we know that force is equal to rate of change of momentum. So the force exerted on the molecule is equal to the rate of change of momentum of the molecule. So therefore it is nothing but m times v minus m times negative v divided by delta t. And simplifying this, we know that it is going to be 2mv divided by delta t. What's the time in which this collision happens? We know that the time of the actual collision is itself very negligible. So we can safely say that if the molecule goes and collides with the wall of this container, the time between two successive collisions of this molecule with this wall is going to be the time taken for the molecule to travel to and fro. So let's assume that the length of the cube is L. So in between two successive collisions of this wall, the molecule will travel 2 times this distance. So I can write the time as distance traveled, which is 2L, divided by the speed. So substituting that here, we can write 2mv. The force exerted on the molecule is 2mv divided by 2L divided by v, which gives us, you can cancel the 2 out, and this gives us mv squared divided by L. Now this is the force on a single molecule. But how many molecules are actually impinging on this wall? So let's say n represents the total number of molecules that are present in this volume of a gas. Are all the molecules moving in that direction? No. There are 3 preferred directions of motion, right? X, Y, Z. So 1/3 of the molecules, 1/3 of the total number of molecules can be moving along any direction at any given time, because there is really no preferred direction of motion. They are in random motion. So if there are n number of molecules, I can say about 1/3, that means n divided by 3 molecules are moving along this direction and therefore colliding with the wall. So the collective force exerted by all of those molecules can simply be got by multiplying that by the number of molecules. So n divided by 3 times mv squared divided by L. This is the force exerted by all of the molecules on that wall. But we are looking for pressure, which we know is force divided by area. So pressure is F divided by A, and the area of this surface of a cube is nothing but side times side, which is L squared. So therefore it will be n divided by 3 mv squared divided by L, and we are going to divide this by L squared, which means it's going to be n over 3 mv squared by L cube. So let's just simplify that expression. So we can write nm v squared over 3L cube. But before that, are all the molecules moving at the same speed? No, we talked about how the speeds of the molecules in a gas is like a distribution ranging from really low speeds to very high speeds. So therefore, instead of writing the speed as v in this equation, we must replace the speed by the average of all the speeds. And it is not simply the average, it is what we call as the root mean square average. What that means is, if I average the squares of the speeds of all the molecules by just adding the squares of the velocities and dividing it by n, I get c squared, where c is what we call as the root mean square velocity or root mean square speed of the gas molecule. So instead of assuming this to be a constant speed, we are going to replace this by the average speed of all the molecules. So therefore, P equals nmc squared divided by 3L cubed. Now this product, n times m, n being the number of molecules and m being the mass of each molecule, represents the total mass of the gas itself. And then L cube is nothing but the volume of the container, which is the same as the volume of the gas. So therefore, we can write pressure as equal to mc squared divided by 3V. Well, we are not quite done. How about this expression, m divided by V? Do you know what this stands for? Yes, so pressure is equal to mass divided by volume, represents the density. So rho c squared divided by 3. So the pressure exerted by a gas can be defined as equal to the density times the root mean square velocity squared divided by 3. Or in other words, we can say that the pressure exerted by a gas depends on two things. It is directly proportional to the speed of the colliding molecules, because notice that the pressure comes from the force, which in turn is related to the change in momentum. And it is also going to depend on the frequency of collisions. Because the rate of change of momentum is going to be more if the collisions happen much frequently. So the pressure exerted by any gas is going to directly proportional to the speed of the colliding molecules and the frequency of collisions. So let's do one more thing, which is, how is the kinetic energy of a gas related to its temperature? This is what we call as the kinetic interpretation of temperature, which we can prove from what we derived here. So we know that pressure is equal to rho c squared divided by 3. Expanding rho again as mass divided by volume, we get mc squared divided by 3. Or in other words, we can rewrite this as PV, multiplying both sides by V, we get PV equals mc squared divided by 3. However, we also know from gas laws that PV is equal to nRT. So if the left hand sides are equal, can we equate the right hand sides? So we can say mc squared divided by 3 equals nRT. But my goal is to determine the kinetic energy of the gas. And we know kinetic energy is mc squared divided by 2. So I want a 2 in the denominator and not 3. So I'm going to multiply both sides by 3 in order to get rid of this. So we have mc squared equals 3nRT. Well, that's not still what we want. We want a 2 in the denominator, so divide both sides by 2. So we have then mc squared divided by 2, which is our kinetic energy, is equal to 3 over 2 nRT. So kinetic energy is equal to 3 divided by 2. N is the number of moles, R is the universal gas constant, and T is the temperature. If I am going to consider just 1 mole of a gas, then I can write this as kinetic energy is equal to 3 over 2 RT, because I took N as 1 mole. So this tells us, because R is a universal gas constant, this tells that the average kinetic energy of the molecules of a gas is directly proportional to the temperature. Okay, so, and we can calculate it by simply using the fact that kinetic energy is 3 divided by 2 R times T. This is for 1 mole of a gas, but we know that 1 mole of any gas contains Avogadro number of molecules, which we will represent it as N times A, where this is the Avogadro number. So that means if I want the kinetic energy of a single molecule, I need to just divide this by the Avogadro number. So which means kinetic energy will be 3 over 2 R divided by NaT. This is a constant because it's a universal gas constant divided by the Avogadro constant, which should be another constant, and that constant is called as the Boltzmann's constant. So Kb is called as the Boltzmann's constant. So this is nothing but the kinetic energy of 1 molecule of a gas, which is again directly proportional to the absolute temperature. So this is what we call as the kinetic interpretation of a temperature. So as the temperature of a gas increases, the average kinetic energy of the molecules of the gas will increase, or in short, they will start moving faster. So having understood what pressure is and what temperature is, can you give an explanation for these 3 laws? Boyle's law, which says that at constant temperature, pressure is inversely proportional to volume. So that means, can you think of an explanation as to why when you keep the temperature constant and as the volume decreases, that means you compress the gas in the container, why does the pressure increase? Similarly, if you keep the volume constant, pressure is directly proportional to temperature. That means when your volume of the container is kept constant, as the temperature increases, the pressure also increases. Can you think of an explanation based on what we have learned so far as to why this happens? Those are the questions that we'll be talking about in tomorrow's class. So we'll see the rest tomorrow.